Yes, very good morning to all. It is audible.
Yes, sir, you're audible. Morning.
Yes, my slides are visible.
Yes, sir.
Yes. Yes, this is what we have seen yesterday. And how many of you joined so far? I think 33 joined. Yes, we'll wait some more time. We'll give time to join. Yes, I think around 40 to 43 people joined. Okay. Yes. Yes, we will start today's session from a puzzle. Assume there is a person using 30 he is trying his office is in the 20th floor. In a daily basis he will go to office, but during rainy season, I think it is audible.
Yes, sir, you are audible.
Yes. A person trying to reach his office is in the 20th floor. During rainy season, in all the time, just a minute. Yes, I think around 50 people joined. Yes, concerning today's class, we'll start from the puzzle. Before that, I request 10 people to join with us till the end. Attendance from right. Serial number 11 to 20, please join with us for today's presentation. I think number 24, 26, 28, 30, 32, 34, 36, 38, 40, 42. You please unmute your mic and please join with us till the end. Nitish Kumar, Hari Prasad, Brinda, yes, Bhatia, is you please unmute your mic and please join with us. Yes, today's we'll start from the puzzle. Okay, is during rainy season, one person usually visit his office, which is situated in 20th floor. In rainy season, what he's doing, he is trying to reach the 7th floor using lift, and then he walks. On the other days, he won't use the lift. He usually use the staircase not to reach the office. And what might be the principle behind this? What was the answer? It is a.
Sir,
Are you getting my point?
yeah,
Yes, yes, yes. Go
sir,
ahead, go
he'll
ahead.
be shocked in that he can't touch the button, so he'll use the umbrella to hit the buttons during rainy season. And during summer season, he can't touch the button, so he'll just use the steps.
Yes, Maitreyan. Very good. Very good. Yes, yes, yes. Very good. Very good. Akshay, do you have any answer for this? Do you have any other different answer?
No, sir, same
Akshay?
answer.
Okay, okay. Okay, okay. One more technical question, see, there is an beer on the hill. See, there is a beer on the hill, and the height of the hill is 20 meters. The height of the hill is 20 meters. Suddenly, it fell down. It took 2 seconds to reach the earth. Then, what was the color of the beer?
So can you see?
There is a beer on the hill. There is a beer on the hill. The height of the hill is 20 meters. Beer is at the edge. Suddenly it fell down. It took 2 seconds to reach the earth. Then what was the color of the beer? Any answer? Amin? Amin, is that?
Hello, sir.
Yes, Amin. Your surroundings are
Yeah,
very noisy. Yes,
yeah, red, sir.
red.
Yeah,
How it would be a red? If
because
it suddenly fell
it
down?
fall down low, so red color will be the blood of the beer.
Yes, definitely, definitely. After injury, there might be a bleeding. I mean, it is fine. But before bleeding, what would be the color of the beer?
Black, sir.
Black. Okay, think. Okay, Maitreyan. What was the color of
White.
the beers? What was the probable colors in beers will be?
White, black, brown.
White,
Black,
black,
brown.
Sir,
brown.
can you repeat the question?
Maitreyan, can you repeat the question, Maitreyan? Amin can understand the question.
A bear is sitting on top, like it's on top of a hill, which is like 20 meters or something. And if it falls within 2 seconds to the ground. So what will be the color of the beer?
Absolutely, absolutely. That was the question.
White.
Yes. How it is white? If it is black, how it is black? There are possibilities, white and black. Is it?
Like it's falling and reaching the ground within 2 seconds, and the height is like 20 meters. So the gravity at that point would be like 10, and where polar areas have the maximum like gravity we feel, and thus we shall say that as white. It's the polar bear.
Yes, Karthikeyan, it is very good, very fine. Can you please elaborate so that your fans can understand the answer? You go ahead and you try to remove the knot one by one.
Okay.
Yes, of course, this is right.
Okay. First of all, height formula is like half into acceleration to t square, and we will be like finding applying the formula height as 20, and half into g formula we don't know. Let's assume that we need to find the value of g, and time is like 2 seconds. So 2 seconds means and 4, and applying that formula we would get g as 10, where g is the maximum. Like the maximum barrier for that, and the maximum g would be at the like the areas of the polar region. So we shall say that the polar, that beer is a polar beer, so thus the color of that is white.
Yes, what was the formula? You were saying one particular formula. What is that formula?
Half into height is equal to half into g to t square. Like I learned this.
H is equal to half into g t square.
T is equal to square root 2h by g.
Yes, Maitrayan.
T is equal to square root 2h by g, sir.
T is equal to square root of
2h.
2hg. Okay, which is derived from, no. A little more clarity is essential. Little more clarity is essential. And you come up with laws of motion, Karthikeyan. There are 3 different laws of motion are available. Karthikeyan, can you please remind the laws of motion?
Newton's laws of motion, right? So
No, the basic laws of motion.
like there are 3 formulas where v square minus u square is equal to half gt square, and v is equal to ut plus half at square, and yeah, v is equal to at that formula we can use, or s is equal to ut plus half at square, where
Yes.
u is 0
Just a minute. I'll make clarity over that. The first law of motion is v is equal to u plus at. In here there are 2 data is available. One is s displacement, that is 20 meters. The other one is time. We have time, t is equal to 2 seconds. There are 2 different data is available, s and t, and there is a possibility in applying with these 3 different equations. There are 3 different equations. V is equal to u plus at 1, and s is equal to ut plus of at square. That is the second formula. And the third one is v square minus u square is equal to 2as. There are only one possibility in applying one equation, because in that v is equal to u plus at, and we have we need to apply the initial and final velocity we don't have, and s is equal to ut plus of at square. We know, we might be knowing about initial velocity, that is 0. Therefore ut becomes 0. S is equal to of at square. That of at square is converted if the particles or a body or a matter took horizontal pathway, that we need to take it as a. If it is vertical, then we need to consider as g, whether it might be towards gravity or it might be against gravity. If it is towards gravity, we need to apply positive g. If it is against gravity, we need to apply negative g. Therefore, s is equal to half gt square. Now go ahead, Karthikeyan.
Yeah, s is equal to half. Okay, fine. The basic formula is s is equal to ut plus half at square, and the bear is like falling from a height. So we shall assume that the initial velocity will be 0, and so that the formula we get is s is equal to half at square. As you said, s is the displacement where the bear fall. The displacement would be for 20 meter, and so 20 is equal to half into, and g we need to find, like the acceleration during this course would be like g, and g into t square we shall apply 2 to the power of 2. With that we will be like getting the value of g, and as I said before, we would be like getting the maximum value for g, and the polar areas have the maximum value of g, so we shall say that as a weight.
Yes, very good. My appreciation, Karthikeyan. You are very strong with your basics. Still, you are remembering the laws of motion, and when we are inquiring about laws of motion, you are discussing. You are ready to discuss about Newton's law of motion also. If when it is out of our area, still if time permits, you are all production engineers. You should be very aware about these laws of motion. When we have time, at that point we will remind these basics, that is Newton's laws of motion and the relation between the force and the relation, the difference between weight and mass, and if it is feasible, we'll discuss some other things related to basic mechanics. Okay, good, good. My
Sir,
appreciations.
shall I try?
Thank you, sir.
Pardon?
Sir, shall I try?
Yes, yes, yes. So I think someone inquiring.
Sir, shall I explain why it's white?
Pranish.
Yeah, sir. Yeah.
Yes, go ahead, Pranish. Go ahead.
Sir, normally bear is weighted animal, sir.
Okay.
When it's falling from height, so height, so white.
Pranish. Yes, this is what we need. We need attention, not to seek attention. We request Pranish when there is a deep silence from the students. At that time, we request Pranish to disseminate like this type of non-technical issues. Pranish, anyway, fine, Pranish. Even after a detailed technical discussion from Karthikeyan, Pranish given. Okay, fine. Okay, today we'll start the hydroelectric power plant. Today we'll discuss in detail about Pranish. You are from which state, Pranish?
Sir, I'm from Tamil Nadu, sir.
Tamil Nadu. Okay, Karthikeyan.
Yes, sir. Tamil Nadu, sir.
Is anyone from UP and Madhya Pradesh?
Anuj Gupta, sir.
Anyone? You please
Yes,
unmute
sir.
your mic. Yes, Tamur. Be aware that the scenario
Yes.
is very poor, very poor. Be aware, be cautious, and
Yes, sir.
we need to be very cautious. The second wave is very huge, and the headlines revealing various informations are very critical, and we be cautious. I request all of you to be very cautious. In particular, the maximum number of cases are huge in these states. That is why I have requested them, but it has to be followed by everyone. Okay, Maitreyan, do you have any points to share? Shall we go ahead with our content?
Yes, sir.
Yes. The energy has to be viewed very seriously, because energy is a very important factor for all the countries. Assume there is no electricity for few days. What happened? And the lighting and heating system and fans, refrigerator no longer operate. Is it right? The computers, the mobile phones, television, and the other communication system become unstable, and even the traffic control lights and other street lights become useless, and the lift no longer will lift the people, and the school, colleges, industries, and the commercial building, etc., become inoperable. So yes, we are 100% dependent on electricity for our day-to-day activities. Is it that? And therefore, power that should be electrical power is the basic necessity for the economic development of the country. So the production of electrical energy and its per capita consumption is deemed as an index of the standard of living in the nation, in that the present day civilization, and the development of industries, agriculture, transport, etc. total depends on electrical power. Therefore, we should be conscious about the per capita consumption. Before that, what is mean by per capita? See, there is in Google search what would be the per capita. Is my search engine is visible to everyone?
Yes, sir.
Yes, sir.
Yes. I think we'll request one to stay with us. And Hari Prasad. Hari.
Yes, sir.
Yes, Hari Prasad. Yes, you please stay with us. Hari, my search engine is visible.
Yes, sir. Per capita
Yes.
income.
Then what might be the per capita consumption? The per capita consumption is the yearly use of goods and service by each person. The consumption by each person. whether it depends based on the it might be some unit missing, whether it might be for an hour, for an year, and something left. Therefore, per capita consumption is consumption by a person, individual, and therefore the per capita consumption of the power. See the other search engine. See, this is what the list of countries by electricity consumption, and it might have some differences with the actual data since it was in Wikipedia data. See, this is what the per capita consumption of the world average per capita consumption. We need to take this one, average per capita consumption. This is what's shorted based on the electrical consumption gigawatt hour by year. Gigawatt hour by year. See, the China is the leading country which generates electrical power, and that too with 72 lakh. Is it right?
Yes, sir.
Yes. 72 lakh 25,500 gigawatt hour per year. When concerning about this one, I am shorting with this. See, we are in the third place. Is it right? The India is in third third position. I am trying to make it this average electrical energy per capita. When I am shorting with this one, and India is far away. See here, the topmost country using the average electrical energy per capita is Iceland, and that too with 51,699 kilowatt hour per person per year. Per person per year kilo. We are using 51,699 kilowatt hour for an hour by person per year, per person per year. And concerning Norway, I am trying to differentiate for a sake of differentiation. I am taking few countries. I am concerning about Norway. See, the Norway per capita consumption is 23,210, and I am taking Australia. See, where is Australia? See, Australia is 9,502 kilowatt hour, and concerning Canada, and see Canada and 14,612. I am concerning about United States, and it was 12,154, and concerning UK 4,496, and concerning Japan, see Japan and 7,150, and concerning India, see concerning India, it is only 935. See, and therefore the high per capita consumption in Ireland, etc., is attributed to the existence of heavy electricity consuming industry and thin population. For our country, the figure is very low. It is very 935 alone, and we have to still go to a long way in power generation to provide a decent standard of living for our people. So it is what the main motto of the one part of your syllabus, and that is what we are going to discuss about the various power plant and the required places for doing or erecting the power plants, and this is what the half of the syllabus we are going to talk about in energy and environmental engineering. And do you have any other countries? Do you need to visit any other country here?
Can you show
Concerning
New
Sri
York?
Lanka, it was 660. New York, yes. New Zealand and New York is a country.
No, sir, it's a place in US. But it seems they use a lot of electricity.
No, that we need to check with the US alone. Okay, any other country? Tell me with some any other country name. New Zealand. See the New Zealand and 8,372. See what happened in Japan. Yeah, two decade earlier, the Japan per capita consumption is only 1,800. What happened in within 2 to 3 decades? It is elevated. It is 4 times multiplied than that of the earlier per capita consumption. That is what we need to learn from Japan. And before 3 decades, the per capita is only 1,800 in connection with Japan. Now see, it is enormous growth, that is 7,150. That is what we have to conscious. We need to increase the amount of per capita consumption. Therefore, the sophistication will be very more. And this is what one side, without harming the environmental. That is the major concern. And along with that keynote, we need to approach this study. Okay. Okay, these slides will visit one by one. We'll start the hydroelectric power plant and see this is what the data which is derived, which is downloaded from the Ministry of Power, our Indian government ministry, and this is what the coal and lignite percentage is very huge when compared to others. That is 55.43% of megawatts can be utilized, produced with the aid of coal and lignite. The total power capacity of our nation is 3,70,106 megawatt, and with that the RE is 23.51, and hydro, as I detailed in the last class itself, it is 12.35, and nuclear it is 1.83. Diesel it is very minimal, 510 megawatt, and gas and 6.74. What we need to be very conscious, this percentage of 23.51 has to be increased, and other rest has to be minimized because we are conscious about the environmental. And this is for gross electricity generation in India and mode-wise utilities. And this is what the gross electricity generation in various countries. And concerning India, see, it was very minimal when compared to China. We are competing China with various factors, whether it might be a population and whether it might be a border issue. And for see here, it is very minimal. And as we are all young engineers, you need to be very conscious about it, and it has to be grown. And the plan-wise growth and some other slides which is related to the power sector and the power plant. And this is what we'll start the hydroelectric power plants will detail about the power plant. Power plant are used for generation of electrical power from the various source of energy, and fuel represents the largest operating expense in the electrical power generation, and therefore we are going to deal with various power plant, and we'll start with the hydroelectric power plant. And one particular video you see, and then we'll come back to these. This is what the block diagram which is essential for doing examinations, and I'll explain what is happening. I think you're all already aware about these power plants. Still we need to have a visit. Yes.
The working principle.
Yes, it is audible. This the video is audible.
Yes, sir.
Yes, sir.
Working principle of hydroelectric power plant. In this power plant, production of electricity depends upon the height of the water from ground level, volume of the water flowing per unit time, and efficiency of the turbines. Hydroelectric power plant requires a water reservoir. So these plants are constructed near big dams.
Before that, can you please remind me what is mean by kinetic energy and what is mean by potential energy? And with that, we will continue this video. Someone please unmute your mic and tell me what is mean by kinetic energy and what is mean by potential energy. Someone please go ahead, go ahead. Someone?
Kinetic energy is energy object
Yes,
contains when it is in motion, sir.
yes, I mean that is
Kinetic energy is an energy an object contains which when it's in motion. But potential energy object contains when it is in a static position.
yes, very good. Yes. The energy stored in the body due to its position is called the potential energy. When it tries to move, it has some energy. That is what the kinetic energy. Okay, you see the rest of the content in the video.
In this power plant, production of electricity depends upon the height of the water from ground level, volume of the water flowing per unit time, and efficiency of the turbines. Hydroelectric power plant requires a water reservoir. So these plants are constructed near big dams. Water stored in dams has potential energy. The water under pressure is carried by penstock and supplied to the turbine through the inlet valve. Penstock is a pipe made up of steel or concrete. A surge tank reduces the excessive water force on the penstock. Here, trash rack prevents the debris from getting entry into the powerhouse. Due to the force of water, the turbine starts rotating, due to which mechanical energy is produced. The shaft from the turbine is connected to the generator. Therefore, the generator produces the electricity. The voltage of this electricity is raised by using a transformer and is transferred by the distribution lines. After running the turbine, the water is passed to the downstream water level by draft tube. The demand of electricity varies by day and night as well as among the seasons. Hence, there is a need to store the energy so that it can be used at the time of high electricity demand. This can be done by using pump storage process. Advantages and disadvantages of hydroelectric power plant. The most important advantage is that it keeps the environment clean. Hydro energy can be stored in high-level reservoirs and used whenever necessary. Electricity is produced at a constant rate. The life of dams and power plants lasts for many decades. The water can be used for supplying drinking water, irrigation, water sports, industries, power plants, etc. Another advantage is that when electricity is not needed, then the sluice gate is closed to stop the generation of electricity. It also allows storage of water to be used whenever necessary. However, the disadvantage is that constructing hydroelectric power plants and dams is very expensive. It requires large area. Another disadvantage is that Planning a hydroelectric plant and reservoir may lead to the disruption of the lives of people living in that area as they have to reallocate to another area. In this session, we learnt about hydro energy, the history of hydroelectric power plants, the working principle of hydroelectric power plants. We also studied its advantages and disadvantages.
Yes, yes. This is what we were learned in the video, and yes, go. We'll talk about the one by one, the working principle, and hydro. As we know already, aware about the meaning of hydro. It means water. And hydroelectric power plant utilizes the potential energy of the water which is stored in the dam. And the potential energy is energy which a substance has due to its position or its state. And the potential energy of the stored water is converted into kinetic energy when it was passing through a pipe. And the kinetic energy of the water is then converted into mechanical energy in the turbine. And when it starts to rotate, it was connected to the generator. At that time, the mechanical energy is converted into electrical energy. And for that, we are using electrical generator. This is what the working principle. And please make a note, each and every point has to be recorded in your notebook. Please, this is what the working principle. And the second one is classification. And concerning the classification, we have three different types of power plants. One is high head power plant. Number two is medium head power plant. The third one is low head. When the height exceeds 70 meters, that was classified as high head. It was less than 15 meters. That was low head. It varies between 15 to 70 meters. That was medium head power plants. And the layout consists of various things, and that is what given in this particular picture. We'll discuss one by one. One is catchment area. The catchment area of the hydro plant is the whole area behind the dam, draining into a stream or river across which the dam is built at a suitable location. That is what catchment area. The water reservoir. This is what the reservoir, and this is what the reservoir. Continuously availability of the water is the basic necessary for a hydroelectric plant. The whole of the water collected from catchment area during rainy season is stored in the reservoir. And see, the power production in our country, the power production is not the main theme of this type of this typical reservoirs. And the storage, and at the time of cropping, when there is a need, at that time only we are using water. And through that we are in the midway, we are utilizing the energy and we are producing the power. The major concern for this type of dams are not to store the waters. We are using dams. In the meanwhile, we are utilizing the energy, and we are trying to produce the power. The capacity of the reservoir depends upon the catchment area and rainfall at the place. The water head available for power generation depends on the reservoir height. And the third one is head raise level. The water surface in the storage reservoir is known as the water surface storage. Water surface storage is the head raise level. And the fourth one is dam. As I already revealed, the dam is in structure of which is some other material built at a suitable location across the river. The function of dam is to increase the height of the water level behind it, and which ultimately increase the reservoir capacity. Not to generate the required quantity of power, it is necessary that the sufficient water head is available. And we have here provision for spillway, and spillway, the excess accumulation of water has to be removed, and that is what an arrangement is provided. that arrangement is called as in spillway. During rainy season, what happened? Water after a certain safe level, it has to be in the reservoir overflows through one pathway. That pathway is nothing but spillway without allowing an increase in water level in the reservoir. And gateway. Gateway is used to regulate or control the flow of water from the dam. A gateway arrangement is provided here, and that is what gateway. And penstock, the pipe which carries the water from the surge tank to the power station, this is called a penstock. The tunnel or a pipe which is used to carry the water from the surge tank from the dam to the power station, that is called a penstock. And usually it is made up of concrete or it might be a steel. And see here there is a surge tank, and surge tank, what was the purpose of surge tank? I'll tell you. When there is when the load on the generator decreases, the gate admitting water might be suddenly closed. See, there is an issue. We need to cut the power. We need to stop the flow of water. What we have to do? We have to cut the flow of the water using some gauge. We are closing like a gate valve. We are using here. We need to cut out the flow of the water. At what time? What happens? The sudden flow dropping will harm the penstock. And due to this sudden decrease in the rate of flow, what happens? The water of the turbine pressure in the penstock, the pressure in the penstock increases suddenly, and this sudden increase in pressure causes hammering action on the penstock. And this hammering action is known as water hammer. And in order to avoid water hammer, there is a provision provided here. And what happens when there is a sudden stoppage in the flow? It has to rise. There is a provision here. The pressure won't allow to rise the water level, and therefore we are providing a separate provision to not increase the level of the water. That is what surge tank. And here there might be a question, and see what is mean by water hammer and what is mean by surge tank, and what is the purpose of surge tank. Like that, there might be questions will be available, will be raised during examination. And yes, do you have any doubts?
Can you search tank again, sir?
Yes, what happens when we are controlling the flow of water? When we are suddenly stopping the flow of water, the flow of water has to be stopped, isn't right? It will increase the pressure of the penstock, and what happens? It is steel. It is made up of steel or concrete. It will suddenly the impact over the surface of that cylindrical portion, and that impact on the penstock has to be called as water hammer. That water hammer has to be removed through some provision. That some provision is called surge tank. What happens? It has to increase in one particular volume has to be provided, not increase the level of the water. And when we are stopping, it has to go this way, and this volume has to be used to increase it allows the stoppage, and it allows the water to get rise. And here it won't be possible because the pressure will be different. And this is what the surge tank. Are you getting my point?
Yes, sir.
Yes. Yes. In other words, the surge tank is introduced between the dam and turbine to reduce the sudden rise of the pressure in the penstock. Otherwise, the penstock will be damaged by water hammer effect. And the surge tank is a small tank into which the water flows, or from which water flow out due to sudden variation of the pressure. And the surge tank also serves as a supply tank, delivering adding water when the water in the pipe is accelerated due to the increased load on the turbine, and as a storage tank collecting water when the water is decelerated due to the reduced load of the turbine. See, in both the cases, we are utilizing the surge time. And the other one is waterway, and waterway through penstock pipe carries water from the dam to power house. Waterway through penstock pipe carries water from the dam to power house. And the turbine, you have seen the clear picture about the turbine. The water turbine is known as a hydraulic turbine. Water through the penstock pipe enters into the turbine through the control valve. The usually turbine is called as a prime mover, which are common user Pelton turbine or Francis and Kaplan. And the potential energy of the water is converted into a kinetic energy in the penstock, and which is utilized as an which is converted as an electric mechanical energy via a mechanical device is called the turbine. Probably it might be called as a prime mover. And draft tube, here there is a provision called draft tube. In the video itself we have given detailed information about the draft tube. A draft tube is provided at the outlet of the tail race. This is what the tail race, the water flow occurs, and tail race. What happens? Water after doing work, the turbine passes to the river through the draft tube. What happens when we are utilizing the energy? There is no power, there is no energy in the water. It will store, and the storage has to be removed through some structure. The structure is nothing but the draft tube. The draft tube is a metallic pipe or a concrete tunnel having gradually increasing cross section. See, there is an increasing cross section will be available. I'll see, this is what the draft tube will be there. It has to be connected in the tail race. This is what the tail race. We have water, and due to this variation in the volume, that might be the variation in the pressure. Therefore, this stored water has to be removed by this structure. This structure is known as draft tube. And the tail race, as you know about, already aware about the tail race, is a waterway for discharging the water from the turbine to the river, or it might be a canal. The water held in the tail race is called tail race water level, and the water from the tail race is released for the irrigation purpose. See, the main purpose of this water is used for the irrigation, and we have the powerhouse. The powerhouse accommodates water turbine, generator, control room, and transformers. The function of the step-up, we are using step-up transformer now to rise the voltage generation, and therefore it has to be through transmitted to other transmitting power for consuming the people not to use the powers. We are transferring the power. And concerning the advantages, we have various advantages. It has a renewable source of energy. Water is a renewable source of energy. Water, which is the operating fluid, is neither consumed nor converted into something else. And the second one is cheapest source of energy. Water is the cheapest source of energy because it exists as a free gift of nature, and fuels needed for the thermal, diesel, nuclear power plants are exhaustible, and also it is expensive. And the third advantage is no fuel transportation, and the fourth one is no ash disposal problem. When we are talking about the thermal power plant, handling ash might be a very big issue. Here there won't be such an issue, and there won't be any pollution also. And variable loads, during variable loads also, the efficiency is very good, and life of the plant is also huge. Around 100 to 120 years it might be the life, and when compared with the thermal power plant, it would be 30 to 40 years. And the running speed of the hydroelectric power plant also low. It would be 300 to 400 RPM, but the turbines in the thermal power plant needs 3000 4000 RPM. At speed only we can able to produce power, but here it won't be an issue. Even 300 to 400 RPM also we can able to produce the power. and the domestic water supply, the water storage of the hydro plant can be used for domestic water supply and easy operation. And the list staff, the count is also required less, and low maintenance is very good advantage of this hydroelectric power plant. However, it has some disadvantages, and transmission losses will be there, and that might be the major drawback in connection with the hydroelectric power plant. And during monsoon, it won't be there. The failure of monsoon, the power produced by hydro plants depends upon the quantity of water. In turn, it depends upon the rainfall, and even the evaporation losses will be there. And the initial cost is huge when compared to other plants. And the erection of plant usually takes to a longer period. And these are some disadvantage of the hydroelectric power plant. And do you have any queries? Any clarification with these hydroelectric power plant? Do you have any questions? Do you have any queries? Do you have any queries?
No, sir.
Yes. Maitreyan, what are the other subjects you have in the present semester, Maitreyan?
So we have maths and physics, applied mechanics. Then we have a physics lab.
Okay. 1, 2, 3.
Engineering practice.
Computer science lab, and then
Computer science, sir.
Okay, mathematics, physics, applied mechanics, energy, and CP, and concerning lab, physics, EP lab, and CP lab. Is it right?
Even civil is there, sir.
Civil subject, civil is there. Okay.
Yeah.
Okay, who is handling applied mechanics subject?
Prakash Kumar, sir.
Okay, fine.
Prakash Kumar, sir.
Oh. Okay, fine. If you don't have any doubts, we'll meet during next class. And I request the Jostana and other representative to share the Saturday timetables. Jostana, coming Saturday, what was the timetable?
Yes, sir. I'll confirm it by today.
Yes. You send the Saturday's timetable.
Yes, sir. This Saturday we are gonna follow Tuesday's timetable, sir.
Tuesday. Okay. Do you send that PDF, Ankit?
Okay, sir.
Okay. Thank you. We'll meet next Thursday. We'll meet.
Okay, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.